What we're going to look at now is the binomial expansion. We're going to look at the first of all, the equation that's given in the formula book. We've already seen what this means, and we're going to focus really on this this bit here, which represents the general term, any term, okay, or the one where b has a power of r, for instance. So it's not a specific power, it's not a power of 2, but instead it's r. So we're going to look at this general term here, and how we can use the general term, not to do the whole expansion, but just focus on a particular term in the expansion. So up until now, in that last example you looked at, you found the expansion up to and including the power of x to the power of 3. Now suppose you get a question like this where it says, here's the expression a plus x to the power of 10, and it wants us to find out the term which has a power of x to the power of 3. So we're looking at the term which has x to the power of 3. We don't need to do all of the terms. We are simply interested in that term. So how can we find that particular term? Well, take a look at our general term given in the binomial expansion. We want to find out when x has a power of 3. What is x in the general term? Which part would it be? Take a look at it. Which part is x? Is it a? It's b. Right, so we're looking at this particular term here. We want b, which is here, to have a power of 3. So we can use our formula given to us in the formula book to figure out just that term without doing every single term in the expansion. You can do all the terms, but why do all of them if the question's not asking for it? You're wasting a valuable time in an exam situation. So how do we go and use this? Well, first of all, make sure it's written in the correct format, and we can compare what we have with what's in the expression. So a is a, and b, as you can see, is what? X. So go here, and what do we want r to be? What do we want our power to be? 3. So let's make a note of those things first of all. We can say a is equal to a. What is b? B is equal to x. And what is r? R is equal to 3. So all I've done is I've taken the general form here, and from there I've written down all the things. There's one more thing missing. Can you see the n? What is n? N is equal to 10. So if we make notes of what each of those individual items are, what n is, what r is, what a is, and what b is, I've covered every single unknown there, haven't I? I've talked about all of those things, and I know what all of those things are from my expansion, the specific one that I'm doing, and the x term that I'm looking at. I'm looking at x to the power of 3. So once you've got that, you can then go back to your general term, and we can write that out first. We'll write that down. I'll write it in terms of NCR, that form, a to the power of n minus r, b to the power of r. I'm going to go and put the things that I'm interested in. What's my n? 10. C, what's my r? 3. My a, from the expression, I can see it's still a, isn't it? To the power of n minus r. Can you see what n minus r is? 10 minus 3. So I'm going to do that straight away. Instead of writing n minus r or 10 minus 3, I've written that straight away. And my b is x, and to the power of r is 3. So what I've then found out is what that particular term is, the term which has x cubed in it, because I'm not interested in all of them. Okay, so if the question said find the expansion in ascending powers of x, then we would use the binomial expansion using the first term, second term, all the way up to the x cubed term. But if it's referring to a specific one, there is no need to do all of them. And you could potentially get a question like that because they might be referring to the x to the 50th power, and you got something which has power of 75. Now you're not going to be sat there doing that whole expansion, so we need to know how to approach that. Okay, so can you now have a go at these 3, please? Let's continue with this. So let's look at this second term here. Quite a big one, this one, quite a large number you can potentially get. And what might confuse you is the fact that the x term is actually written at the beginning, and so it would be a to the power of n minus r. But suppose you didn't want to look at it that way. Suppose you wanted to just change it up. You can do that. You can simply rewrite this bracket as -1, that term being at the beginning, and then the plus 2x term, because that's essentially the same thing. The bracket inside still remains the same. All I've done is I've just changed that. Would that change everything? No, it's absolutely fine, because it makes our maths a lot easier now. So then we can go and compare it to what we had before. A is equal to -1, B is equal to 2x, n is equal to 75, and r is the power of x that we want. And in this particular question, they wanted us to find the power of 50, x to the power of 50. So we can write r is equal to 50. So then we can go and use our general term from the binomial expansion, which is NCR a to the power of n minus r and b to the power of r. And here we've got 75 c 50 minus 1 to the power of n minus r. So that's 75 take away 50, which is 25. And b is 2x. Be careful, it's 2x inside a bracket. You would never write down 2x to the power of 50 like that, because r is 50, because that implies the power of 50 is only on the x. It's on the whole thing. It will be the same as 2 to the power of 50, x to the power of 50. So if you didn't put a bracket, make sure you add that, otherwise it would be incorrect. We don't need to expand this. I mean, it was a process of looking at how you would simply find that particular term. The question might then go on to talk about something about the coefficient of this term is 80 or something like that. Go and find out what r is or something, if r was an unknown, for instance. But here we actually know everything about it. So that was an example of how we find a particular term. Let's go and take a look at the next bit, which is how this can then be used in problem solving questions. So we've got a few examples here. Let's look at one example. So let's take a look at this one here. Actually, we'll go and do this one, and then you can try some more challenging questions. So if you look at this example here, we are looking at this expansion. It hasn't asked us to find the full expansion, has it? It hasn't asked us to find out the first 3 terms, 4 terms, or any of that. It simply wants us to focus on the term with x cubed in it and the term with x squared in it. Okay, so if it wants us to do that, we would go and start by looking at our formula here. Let's bring that down. Have our formula book turned to the correct place. So we're simply focusing on the x cubed term and the x squared term. So if we were to rewrite this in this particular form, is it rewritten? Is it written in that form? Is x where we want it to be? Yeah, okay. So let's go and actually compare what a is. So a is equal to 1, b is equal to ax, yeah, ax, n is equal to 10, and for this x cubed term, r is equal to 3. Okay, so that's for the x cubed term. So let's go and work out the x cubed term first. So remember, here is our general term. So we're going to be using 10 CR, which is 3, a, which is 1, to the power of n minus r, which is 7, and then b, which is ax, to the power of 3. Okay, let's go and tidy that up a bit. So we're going to simplify this. So we'll work out what 10C3 is. That's 120. 1 to the power of 7 is 1. And ax all to the power of 3 is the same as a cubed x cubed. So this becomes 120 a cubed x cubed. We then need to look at this term. I know it says something about this coefficient of this being double the coefficient of x squared, but in order to get there, we need to then find out what the x squared term is. Oh, sorry, it's a 120 there. So then we can go and take a look at the next term. So we've got here, first of all, a is equal to still 1, b is equal to ax, n is equal to 10, and the only thing here that's changing is r, because we're looking at a different power of x. We're looking at r to the power of 2. Go and rewrite everything. So it will be 10c2 1 to the power of 10 minus 2, which is 8, and ax to the power of 2. Tidy this up a bit. So we would work out what 10c2 is, which is 45. 1 to the power of 8 is still 1. And ax all squared is the same as a squared x squared. Tidy that up, 45 a squared x squared. So there's my x squared term, and here is my x cubed term, which was mentioned in the question. And then it goes on to say here, a is a non-zero constant, and the coefficient of x cubed. First of all, let's look at this coefficient of x cubed. Where is this coefficient of x cubed?
Everything before x cubed.
Yeah, it's everything. So the coefficient of x cubed is everything before x cubed. So it's referring to this bit here. And it also mentions here we've got the coefficient of x squared. It's everything that is multiplying the x squared, so the 45a squared here. And then it mentions that, well, in that same sentence, it mentions that coefficient of x cubed is actually double the coefficient of x squared. What that means is this is bigger, isn't it? It's twice as big as the other. So in order to set up an equation means that they must both be equal. We would then times which one by 2? The smaller one, yeah? So we would times 45a squared. We would times this by 2 in order to make it equal to 120a cubed, because at the moment a cubed is double. Another way you might think about this is by writing it as follows. We know this to be double of that. So if we did the larger one, 120a cubed, divided it by the smaller one, 45a squared, then it should give us 2, because we expect the larger one to be double of the other one, as they mentioned. And if you rearrange this, this would have given you 120a cubed is equal to, multiply both sides by 45a squared, 2 lots of 45a squared. So you can see you get to the same thing on the other. So there's 2 ways of thinking about it, of how to set up that equation. Now, once you've got the equation set up, we are now in the place where we can simplify this and look at what the question's asking us to do. Find the value of a. So let's go and take a look at this. We've got 120a cubed is equal to, if we times that by 2, you get 90a squared. So it looks like an equation involving a. It looks like highest power is 3 there, so it looks like it's a cubic. How do we solve this? How do we solve any equation? We make one side equal to 0 first, and then we go and factorize, which is the best form to have anything in. So 120a cubed minus 90a squared equals to 0. What's the highest common factor in both of them? Yeah, so we've got a squared, but also we've got 30 goes into both, right? So 30a squared, and we'll have 4 here, 4a. 30 times 4 is 120, and a squared times a. And then we've got minus 3 here equals to 0. When something is in a factorized form, which is the best form to have it in terms of solving, sketching, etc., we can go and solve this quite easily. So each factor must multiply to give an answer of 0. Therefore, 30a squared is equal to 0, or 4a minus 3 is equal to 0. This implies that a squared equals to 0 over 30, so a is equal to 0. But the question actually told us that a is a non-zero constant. Therefore, we would not include this in our answer. We'd just put a line through it, but we've done it to consider it. And so we'd go and find out here a is equal to 3 over 4. That's our answer. Okay, you wouldn't leave both. If you left both of them, you would lose a mark. You need to use every bit of information given to us in the question.